Triangular Matrices. I'm Rodh Spring 2022, Math 141, Section 2D. So what are they? So basically, you want to imagine a square matrix and draw a diagonal line starting from the top left-hand side corner to the bottom right-hand side corner. And we want to basically, depending on those values that are above and below the diagonal line, we determine whether they're upper or lower triangular matrix. So how do we do that? So the values below the diagonal line are 0, then we call that an upper triangular matrix. If the values above the diagonal line are 0, then it's a lower triangular matrix. Okay, so let's look at an example. So you can see this triangle right here, right, is formed basically by a 0 here. And this triangle is formed because these are numbers, right? And these are all 0 values on this side. And same for this side as well. So kind of form the triangle that way. So let's look at another example. So as you can see, as how I was moving my cursor, you can see that all the 0 values here are below this diagonal line, which makes this an upper triangular matrix. And all these values zeros are above this diagonal line. As you can see, there's still zeros within. There can still be zeros within this because they're still matrices. And yeah, and just to note that this is a 3 by 3 versus a 4 by 4, which is why it looks a bit different, but not really in terms of like just the design aspects. This is still a lower, this is still an upper, and this is a lower. So yeah, so let's go ahead and look at some properties of it. So here we have, so if you multiply a lower triangular matrix with an upper one, you get what's called a LU factorization or decomposition. Multiplying two lower triangular matrices will give you a lower triangular matrix, and multiplying two upper triangular matrices will give you an upper triangular matrix. So let's go ahead and just look at what is LU factorization, right? So it's basically A equals LU. L stands for lower triangular matrix, and U stands for upper. So again, this looks a bit different because there's only 1 0, but that's because it's a 2 by 2 matrix, right? So yeah, as you can see, you can still draw the imaginary diagonal line and just basically see, hey, are the values above the diagonal line 0 or below it is 0, and tell which one is the lower and upper, right? And so yeah, let's go ahead and do a practice problem of this. So here I have a system of equations set up, and we're trying to solve for x, right? So here we can use the LU factorization and try to solve for x. Ax equals b. And so this A can be treated as my U matrix, right? And so we're just going to row reduce this U matrix into a row reduced echelon form, and that'll actually give us an upper triangular matrix, believe it or not, and we'll see that at the end. And for L, we'll start it as an identity matrix, so this is just the standard identity matrix. And so we're trying to make this into a lower triangular matrix, right? So that'll be our goal, and we're trying to make this matrix into an upper triangular matrix by row reducing it. So let's try to go ahead and row reduce it, and R2 minus 2R1 for the second row. And don't forget this equation as well, A equals LU. So when we do that, the U matrix looks like this. And then we are transforming our L matrix as well, so do not forget that. So we need to put coefficient 2 at row 2, column 1 because we did R2 minus 2R1, right? So it'll be 1, 0, 0, 2, 1, 0, 0, 0, 1. So next, we do R3 is equal to R3 minus 2R1 for the U matrix, which is our upper triangular matrix. So remember that L stands for lower, U stands for upper. Very important. So now, if we take a look at a matrix, it is U equals 1, negative 3, 1, 0, 1, 2, 0, 4, 9, 4, 9, right? So if you're kind of seeing a pattern that's trying to develop. So we're slowly getting towards our goal here. So we need this 4 to become actually 0. So how are we going to do that? Well, we just still row reduce, but for now we also need to transform this L matrix. So we put the coefficient 2 at row 3, column 1. So now it's 1, 0, 0, 2, 1, 0, 2, 0, 1. Basically, we did that because of R3 minus 2R1. So L equals 1, 0, 0, 2, 1, 0, 2, 0, 1. So you can start to see that this is forming into a lower triangular matrix, right? So I still need to go a bit further. So next we'll do R3 equals R3 minus 4R2. And voila, you'll get U matrix to be 1, negative 3, 1, 0, 1, 2, 0, 0, 1. And you know that this is row reduced echelon form as well. And you'll see that based on the pattern, we draw the diagonal line. The zeros are below it. So it is an upper triangular matrix, right? And so for the L matrix, we put the coefficient 4 in row 3, column 2 because R3 minus 4R2. And ta-da, we get our L matrix to be 1, 0, 0, 2, 1, 0, 2, 4, 1. and draw the diagonal line. The zero values are above the diagonal line, make this a lower triangular matrix. So we did it. We found our L and U. So what's next? Well, we still have to solve for x. So we can break it into two components, ux equals y, ly equals b. So we're going to do the ly equals b component first. So we have our L matrix, right? And we pretty much just matrix multiplication throughout. Y1 is 0, and then we plug in 0, y2 has to be 5, and then 5 times 4, 20, 22 minus 20 is 2, so y3 would be 2. So we got our y values. Now we do ux equals y, so we need to solve for x, right? And so we just do matrix multiplication again, and we'll get, yeah, x1 minus 3x2 plus x3, all this. We plug in x3 as 2, so we're starting to work the opposite way than we did for the lower triangular matrix, right? So yeah, and then we'll see that x1, x2, x3 equals 1, 1, 2, and we're just plugging it back in to check if it works, and it does based on this math. So yeah, we have solved it, so that looks great. So let's look into why do we use any of this, for what purpose, right? So we can solve system linear equations, but we need to also use it in real world applications. So we can use it in machine learning models and data sets. So basically we can use LU factorization to compute with matrices faster and more efficiently. We can use it to help solve linear regression problems. Something with by using least square optimization, which is something we're not going into, but just know that that also uses LU factorization as well. And this is a sample data set, right? And as you can see, it has training data, test data, and all these things. So yeah, that is about it. Thank you guys so much.